we were sorting out some old videos and we came across a video of an old Windpower project that we built on this site here. So I thought it might be quite interesting. It was based around, the generator was based around a mobile welder. They were called Mighty Midget or something. And effectively it was 18 permanent magnets and 18 coils on a fairly heavy duty shaft. So you could rewire it all, reconnect it all, and actually what we had was 9 coils one side, 9 coils the other, a rectifier on each one feeding DC down the pole. So that was that. And because the way it was built and because it was AC brushless, the shaft stuck out the back. So what we did was, to control everything, we put a flyball governor on the back of the wind shaft. So I'm just going to show you this. This was a excess wind sensor. So when the wind get above a certain speed, these flyballs would fly out and it would shut the whole system down. So just to stop the hysteresis in the tail governing system, because the tail on this particular machine was electrically driven. So the flyball on the back of the wind shaft, which operated the motor, which effectively the flyball came out, operated the micro switch, made the motor run, and then as the tail came round, the flyball would ease off and there would be a middle position. We also got a capacitor on the relay that operated the motor, so therefore there was that middle section where nothing would happen. And then of course, as everything slowed down and the capacitor on the relay flattened, then it would open up again. But above a certain wind speed, what we wanted it to do was to just shut down, that's it. So I'm just going to show you this, as maybe some people have never seen a flyball governor. So here we are. Let's just turn it round. What we've got is, it's a pair of washers actually, but it's a track inside which this runs. So as this, it's a bit seized up now, but as that flies out with these weights, this arm moves. That's the basic thing, and as the centrifugal force reduces as the rotation slows down, the revs, it drops back in. And of course this is designed to be standing upright, so it's the weight of these that pulls it back in. Quite simple really, very effective, and you can adjust the weights, and it's just the weight, how far out it is and how heavy it is. So both of those will affect how this governor works. Centrifugal force makes it fly out like that. So that's that. We'll look at some of the video and then we'll intervene at certain points.
It's amazing when it just gets going.
Yeah.
Right.
On the next clip, and I've got some notes here, we can see the flyball governor in operation on the back of the wind shaft. Now we've got the whole turbine and pole tilted over, and we'll cover how we get that back up later on. But it's all tilted over, the cover's off, and the first thing is I'm showing you the micro switch. That's the micro switch that makes the tail start shut down. So effectively the micro switch is operated, and I'm assuming at this point it will be in a normally open but operated, and then as the flyball governor lever moves away from the micro switch then creates contact and starts the motor driving. So we've got various bits and pieces here showing you how the flyball and the governors work. And then we move on to seeing the motor. There's a motor and there's a yellow flexible drive that drives a rack, and the rack moves the tail. So, and then either end of the rack there is another industrial micro switch that is effectively a limit switch for the rack. And that rack is actually one of those old wind up car jacks that you'd get on minis and stuff like that. They're about this tall, a little windy handle here and a peg that wound up on the thready bar. Well, absolutely perfect for that, taking a fairly slow DC motor but slowing it down even more, so you've got a very slow movement. So how did we get this pole tilted over and put back up? Well, it's just a pole. So the pivot for the pole was at about 9 foot up. So you've got two big lumps of steel coming out of the ground and then a pivot through. And thick wall tube and nice big solid pins and all that lot. And then at the front of that I had a ram out of a forklift, a main mast ram, and a 24 volt DC motor running in a hydraulic pump. Nice and easy, not a bother, just set it going, and as you can see it winds the pole right up very nicely. There is a section here showing some of the early batteries we had. These were emergency lighting batteries, proper stationary batteries. Very heavy, very thick plates. I believe these were 300 amp hours, but they weighed over 50 kilos each. This section is with the turbine going, but the wind is quite low, so it's the tail that's moving rather than the blades moving out the wind. If there was a bit more wind, the pressure on the rotor would make sure that the tail stayed facing into the wind, and the rotor would turn like that. But in this case, because it's a very, very light wind and it's just tickling round, it's the tail that's moving like this because there's insufficient wind. But it just gives the idea that the tail moves like this and back again. And as we said, there was a capacitor in the system that stopped hysteresis. So once it had moved, it would stay there for a while and then come back. And then we've got this over wind speed protection here. It's all really early stuff. This was the back end of last century. So, you know, experiments, homemade blades, making your own turbines, making it out of what you've got and what you can pick up.